going. All right, we're doing adding and subtracting today. Here's the only rule that you got to worry about with adding and subtracting these radicals. The radical part has to match. In other words, this has to match before you can add or subtract. Now, obviously, these do. 4th root of 6 and the 4th root of 6. So if that matches, add your whole numbers out front. So 6 plus 2 is 8, and it's still on the 4th root of 6. So the root part doesn't ever change. You treat it like a variable. You treat that radical like it's a variable. So that would be it. So if they're the same, those are easy. We'll take those all day long. But after we do a couple of these, we're going to look at they're not the same. And that's not that bad either. All right, so let's look at the next one then. Notice the radical is the cubed root of 2, both of them. So we can just go ahead and handle our numbers there. So what are we looking at here, guys? 7 minus understood 1 there. So treat that as an understood 1 when they don't show it. So that would be 6 on the cubed root of 2. Done. All right. Then when we look at the next one does have variables in it, but it doesn't really even matter. It doesn't matter that we got variables here because notice they're the same. This is the same as this, so we're not going to do anything to it. We're just going to move it on over. So here we've got 10 minus 6 is 4. Keep the radical. So even with the radicals, it's not difficult there. Okay, so far? Because the next one we're going to make different. Gabby, you with me back there? Greg, you with me up here? All right. All right. So let's do different now. Now this is where we get into what we did before. Because look at this. Obviously these aren't the same. So therefore we're going to have to try to work on this one. So this is what we were doing before we got out. We're going to break it down with a little factor tree. See if we can simplify. So I'm going to go to the side. Do a little factor tree for 48. This is basically what you did in the warm-up. Get 8 and 6. Thank you. All right. So I'm going to break it down to primes. So when I'm going to go ahead with the 8 here. And 2 is done. And here.
2 and 3.
All right. Now, you know, you could have done different factors. And as long as you get done and you got 4 2s and a 3, we're good. All right. So here's what we've got so far. Instead of 48, I'm going to call it that. 2 times 2 times 2 times 2 times 3. That's fine. That's fine. I still know a lot of people who need the visual, so you're good. All right. Now, since it's been a while, what's my index?
4.
The 4 out here. Good. So the index is the number out here on the root. That tells me how many I need to make a set or a group. So I need 4 if I'm going to circle and take it out. So I have 4 2s conveniently. So I'm going to pull out a 2. Remember, you don't really pull out 4 of them. If I have a set of them, then a 2 comes out. If I have 2 sets, then 2 of them come out. All right, so that would be 2 coming out and the 3 staying in. So this, well, I'm not even going to circle it. Go ahead.
So the index will just tell you should have 4 or something, or that number of something.
Yes.
And then you can just bring it out.
This is how many to make a set. That number is always how many. And that's going to change. It changes problem to problem, so we have to pay attention. All right, so the 2 came out. Here we are. Now let's go back to the point of this. Now we're going to add this. The whole point was we want to be able to add. All right, so now look, we're both of them 4th root of 3. So now we can add. So what have we got?
3.
All right, 3 on the 4th root of 3. Or you can just say 3 root 3. And I know what you're talking about. That is it. So even though we had to do work, wasn't bad.
You still got it.
We got it. All right, so far so good, Pedro? All right, let's do it again. Let's do it again, we'll be better this time. All right, 250, actually it breaks down kind of easy.
25 and 10.
All right, so 250 is 25 and 10, and the 25 is 5 times 5, and the 10 is a 2 times 5. So actually that one kind of breaks down easy. All right, so this, I'm gonna say is now 2 times 5 times 5 times 5. All right, so how many does it take to make a set here? 3, because my index is 3 out there. And conveniently, we have 3 of those. So what is it gonna read when I fix it here?
32.
Yes, y'all are good. I know it's hard to put that. 5 on the cube root of 2. There's that. All right, now let's not forget, here's the point. We wanted to be able to subtract, so let's bring down minus that equals, yes, 4 on the cube root of 2. Yes, yes, to both of y'all. All right. Go ahead, I'll wait and see if everybody's, Pedro says. All right. We got a couple more to practice on here. 2 more, I think. All right. All right, let's try another. Now, this one, look, you can have 3. You can have however many. But the numbers aren't as bad here. Let me show you a quick way I do. If it's a small number, here's what I do. Instead of doing factor tree, here's what I do. 12 is 2 times 6. I'm going to put down the 2 because it's prime, and I'm hold 6 in my brain, but I know 6 is 2 times 3. So if that bothers you, don't do it that way. Do it over to the side, but there's 12. I could do 75 pretty easily. What times what?
25.
All right, so the 3 I'll write down, and then the 25, that'll break down, and then you're done with that. All right, and then that minus the square root of 3, it's not going to break down any, so it's just there. Okay? All right, what's my index? 2. Very good, Tia. Understood 2. When there's nothing there, it is an understood 2. So that means it takes 2 to make a set for me to pull out. So here, obviously, I can take out this. 2 on the root of 3 is what that becomes. Plus 5. Yes. And then that last one, nothing happens, so bring it down. Make sure y'all are good with that. All right. Now notice, they're all on the root of 3, so we can just go through and add the numbers. We got 2 plus 5 minus understood 1, which would be 6, because that's 2 plus 5 is 7 minus 1. So 6 on the root of 3, done. It's not that bad. Huh?
No, yeah, that's right.
That's right. It's understood.
Wait, how did you get 6?
I went 2 plus 5 is 7 minus that understood. Yeah, that's okay. Now while we're here on this one, I'm going to do a what if, and you don't have to copy it if you don't want to. I just want you to think with me. But I'm going to say what if, and look, here's why I'm doing this what if. First period had trouble on the problems, and it was this. And so once I show you, it won't be an issue for you. But pretend, instead of having what we just did, maybe you had 2 on the root of 3, plus 5 on the root of 3, minus 3 on the root of 5. So look, these match, and that one doesn't, because it's on the root of 5. So if you get something like this, these two can combine to be like 7 on the root of 3, And that one's not like terms with them, so there's really nothing you can do with it but to do that. So it's okay if you got a couple that match and one that doesn't, just combine what matches and just bring the rest down. So don't let that mess you up. So that was what was bugging him. All right, one more. And this one's got the letters and it looks yucky, but we can do it. Yes, we can. All right, so let us do that. All right, now, notice this. Notice this. We already got 7. So whatever we pull out and put here, what are you going to do with that 7? And multiply. So like whatever I pull out from here is going to multiply by 7. So if you already got something there, that's what happens. What can come out of this? An A. One set of A's. Now I'm going to show it to you because I tried not to show it earlier, and you can see it, and some people can see it, but some people need the visual here. And it's not even that you're not as smart or not, or you are, it's a visual thing.
So you're gonna
Pull out
do
7
whatever
A's.
the-
So yeah, so we're going to pull out 3 of the A's.
Okay.
That's all we can pull out. So what do I call it out front then?
7A.
7A.
Square of 2A squared.
Yes, good. Now here's what happened, and this was smart kids, I just didn't show them the visual. When they did what Tia said, they looked at it from here and they said pull out, because you can circle 3 A's. When they put it out here, they wanted to call it A cubed,
Okay.
because their brain, you know what they were doing. So then when we did this, they were fine. So this is what you got. Okay, now let's look right here. Obviously we got to break this down. That'll fix. The A squared, what you,
It stays because there's not 3.
right, so we really just need to worry about breaking 128 down. So, numbers, I don't even remember.
2 and 64.
Thank you. Nothing was coming to my brain there, which is usual. But all right, so 2, and then I'm gonna go 8 and 8. I don't like it when there's lots of 2s. Seems tedious. 2, 2, 2, 2, 2, and 2 and 2. Yeah. Okay, so here's what we got in long form.
12 twos.
Yeah, it looks like it. 1, 2, 3, 4, 5, 6, 7. Okay.
Close enough.
700 is what it feels like. All right, so I'm gonna put 7 just for our eyes to see, and then 2 A's. We already know the A's aren't doing anything. All right, so there's where we're at. Now this is fixed right here, so I'm just really needing to fix this. Do what? Okay, let me see. We want groups of 3, so we got a group
Yeah, just 1.
and a group, yes. So a 2 comes out and a 2 comes out, which makes 4. Anything you take out, more than one item, you multiply. So it would be 4A, because the A is already there, and the 2 times 2. Is that not right?
Now there's 6.
There's 3.
A 2,
Circled.
now, this is the little index number.
Oh, so you can take 2 pairs.
Yes,
Okay, I didn't
yes,
know that.
okay. I knew you weren't clicked in there for a minute. All right, so a 2 times 2 comes out with that A, so that, and cubed root of 2A squared, that's what's left right here. All right, now, good, look, matches, matches. So we can say 3A, all right. 7A minus 4A is 3A, yeah. On that, yes, yes, good. So once you get that set, it stays that. Are we pretty good?
We're good.
Very good.
Why do you keep the A
Pretty decent.
Why do I keep the,
on the outside? Because 7, 8 minus 4.
Trying to do this work.
you answered yourself, didn't you? It's okay. All right, on, you can stop. On the worksheet,